Hello everybody, Mr. Milks here with video number 6. Today we will be looking at the properties of matter, the changes that it can go through, and how do I separate it. Seems like it's all a lot there going on, but really these things all really do tie together very nicely. And then we will finish, of course, with our 4th Google Classroom assignment for homework credit. So here we go. Physical properties are specifically the constants of a substance that I can observe, such as melting point, color, texture. These are physical properties. And physical changes is something that changes that occur that do not alter the chemical properties of that substance, like cutting it up or melting water. It's still water at the end of the day if I melt it or if I freeze it. So the stuff is still the same, just in another form. If you take a piece of paper and you cut it up, you just have a pile of cut up paper. But it's not something different. So all I did was go through a physical change. It might look a little different, but it's not really a different thing. Okay? Chemical properties are the behaviors that substances adhere to when they react with other substances. So the key word there is usually reacting, becoming. Okay? There's a change going on. So these chemical behaviors are seen when I actually do something to the chemical. And then a chemical change then is the change that I'm talking about. So the change that alters the composition of a substance. Burning or rusting are great examples. When I take paper and I burn it, it's no longer paper when it's done burning. Now it's ash and carbon dioxide and water. When iron rusts, it's no longer iron anymore. It's oxidized. So now it's actually rust on the outside. It's not iron anymore. So the substance has to become something different after the change. That's a chemical change. We're just going to need a little bit of practice so we can differentiate between physical changes and chemical changes and how we go about doing them. Okay? Separation. First separation we're going to look at 3 of them in a little bit of detail, is filtration. This is one we'll be able to do a lot in lab. Let me see you draw a little picture, something resembling close to what you see here. Okay? And basically what's happening is I'm going to separate like sand and water, for example, the solid residue from the liquid. And the reason why this filtration technique works is because the sand does not dissolve in the water. So therefore it's heterogeneous, 2 different things. Filtration will be used something for heterogeneous mixtures. You feel free to write some side notes on the side of this paper now, because I said heterogeneous mixture. Do you think that's something you might want to write? Just because I didn't have it pop up in blue and white doesn't mean it isn't important. Okay? Sand is also too large to pass through the filter. So that's where it actually separates from the liquid as the liquid falls to the bottom. So because it doesn't dissolve and it's too big for the paper, I can filter out the sand from the paper. One separation technique. Another separation technique is evaporation. So this is one how I would separate, say, salt and water. Because see, salt actually dissolves in the water. So it will pass right through the filter. So I can't filter out salt from water. So what I end up doing is I heat it. The water will evaporate off, and then it'll leave the salt behind. Because salt will not evaporate at whatever temperature that Bunsen burner is at. They have definitely a different melting and boiling point. Okay, so the water will evaporate and the salt will not, and I can separate the salt and the sand that way because the salt and the water that way because the salt does dissolve where the salt didn't. Wait, why am I saying, Milks? You're really screwing yourself up. The salt and the sand are different. Salt dissolves, sand doesn't. Whew, all these S words, Milks. Separating liquids by boiling point, distillation. This is a cool picture right here, right? Distillation is a fun thing that we can do in lab. This is like organic part of chemistry. And this is something I'll actually do to make purer water to make chemicals with that we're going to use in lab. And the way this works is I take 2 different liquids together in this impure boiling apparatus. So over on here, there's 2 different liquids together. I'm going to be able to separate them based on their boiling point. If I heat them up, one liquid's going to boil off because it has a lower boiling point than the other, and the one that doesn't boil stays. It's going to boil off, come back down through this condensing tube, and that's where it's going to get cooled. The liquid that is boiled off is cooled and then reformulates here, and I've actually separated the 2 liquids using a distillation technique. So you need to know distillation is used to separate 2 liquids based on boiling point. Other physical separations that we won't use so much that have to do with molecular size or magnetism. One example would be chromatography. You probably did this in living environment when you did the pigment of a plant cell, right? When you had to make connections. This is going to be based on particle size. There's many different chromatographies available to us. There's high pressure liquid chromatography, there's gas chromatography, there's paper chromatography, all used to manipulate different physical and chemical attributes to separate them from one from another. Okay, and magnetism's a way I could say separate iron shavings from wood file or wood chips. I could run a magnet over the top and it would pull up all the iron. But not many metals are actually magnetic. So iron and what else is magnetic again? Iron and who? Maybe nickel? Yeah, mostly just iron though. So your classroom assignments, complete all of your written notes on page 22 and 23 of your boot camp packet. Complete your online Google Classroom portion of your homework. Come to class prepared to go over pages 24 and 26 in class tomorrow. And observe some separation techniques and participate in demonstrations. I will do some of these for you in class so you get to see them. All right, be well. Thanks for watching, guys. See you tomorrow.